Ladies and gentlemen, welcome to this lecture on solar charging of electric vehicles. I'm Gautam Ram and I'm an assistant professor at the Delft University of Technology. In this video, we will talk about the different ways to implement solar charging of electric vehicles. And we will discuss the benefits of integrating solar energy and electric vehicle charging on direct current or DC-based power exchange. There are two ways in which you can charge electric vehicles from solar energy. The first way is to install solar panels on top of the parking lots or on top of nearby buildings. And the second method, although not so common and getting popular, is to put the solar panels on top of the vehicle itself. The image shows a Nuna 9 solar racing car from TU Delft with about 2.6 meters square of gallium arsenide solar cells with an extremely high efficiency of 30.5% and weighing just 140 kgs. For solar photovoltaics or PV systems that are on board the electric vehicle, the typical drivetrain of such a vehicle comprises of several components. The solar PV panels are connected to a unidirectional maximum power point tracking or MPPT converter that ensures that the solar array is operated at its optimal power point and the voltage of the PV array is matched with that of the high voltage bus inside the electric vehicle. After that is an optional bidirectional DC to DC converter that can send the solar energy power to the car's battery or provide energy from the battery to the motor. From there, a bidirectional DC to AC power converter or inverter provides power to the electric vehicle's motor to propel the vehicle forward. And finally, another DC to DC converter is connected to the high voltage traction battery to provide low voltage power, typically at 12 volts, to power vehicle auxiliaries like lights, displays, or windows. The key benefit of this method of putting the PV on top of the vehicle is that you can charge your electric vehicles from solar energy under all circumstances, whether the vehicle is being used and moving or if the vehicle is parked. And clearly, this ability to charge continuously the vehicle using onboard energy translates to the need for a marginally smaller battery in the electric vehicles with an onboard PV system. Also, the smaller battery implies a lighter vehicle overall, which then translates to a lower energy consumption of such an electric vehicle. So, putting solar panels on board makes the entire electric vehicle more energy efficient. For example, Lightyear 1 is a commercial electric vehicle with 5 meter square PVs panels which are integrated on the vehicle, which can provide up to 70 kilometers of range per day depending on the solar irradiance. Of course, this added range will be much lower on a cloudy winter day. This, combined with the energy efficient design of the vehicle with low drag coefficient in wheel motors, the Lightyear 1 needs only 83 watt-hour of energy per kilometer, resulting in a very high range of 725 kilometers. Another way to power electric vehicles with solar photovoltaic systems is by placing the solar panels in the parking spaces or on top of nearby buildings. In this case, a DC to DC power converter operates the solar panels at the maximum power point. Then a DC to AC inverter converts this DC power to 50 Hz or 60 Hz alternating power required in the grid. Alternately, a single stage DC to AC power conversion is possible as well. And then from the AC grid, we have an onboard AC or off-board DC direct current electric vehicle charging system that converts the AC power to direct current or DC power that is fed to the electric vehicle battery. There is, however, one crucial disadvantage with this method. Photovoltaic panels and electric vehicle batteries are both fundamentally direct current or DC by nature. And in this method, the DC power is unnecessarily converted to alternating current AC power and then it's converted back to DC power, resulting in additional power conversion losses and requiring two DC to AC converters, one for the PV and one for the electric vehicle. Hence, a more efficient way to charge electric vehicles from solar panels is to exchange power directly on direct current DC. That is, to connect the solar panels, which is on DC electricity, to electric vehicles which are also on DC, by integrating the two power converters into one single integrated unit. For example, at the Delft University of Technology, we have developed a 10 kilowatt solar powered direct DC charger with our partners PRE and Last Mile Solutions. It has three power converters: a DC to DC converter for the solar panels, a DC to DC isolated converter for the electric car, and a DC to AC inverter to connect to the grid. The key benefits of this design are that the solar inverter and electric vehicle chargers are integrated into one converter, allowing direct DC charging without converting the power to AC. Secondly, only one DC to AC inverter is needed for both the solar and the electric vehicle instead of two, saving both space and cost. Both the inverter and isolated DC-DC converter are bidirectional in this design. Therefore, you can not only charge the vehicle from the grid, but also send the energy from the electric vehicle battery back to the grid as well. This unique aspect of combining solar charging and vehicle to grid is that the electric car battery can now be used to store renewable solar electricity as well. Now imagine a scenario where your car charges at the workplace from solar energy, and then you drive back to your home and you can power your home in the evening using vehicle to grid technology. Finally, this DC system facilitates 4 different unique power flows and its combinations. The first one is from the solar panels to the electric vehicle for solar charging of the vehicle. Second, if there is no solar power, the system operates as a conventional DC electric vehicle charger. Third, the charger is itself bidirectional, therefore it's capable of feeding power from the electric vehicle battery back to the grid via vehicle to grid technology. And finally, if there is no electric car, then the whole system acts as a solar inverter and feeds the solar energy back to the grid. So let's summarize this lecture. We talked about solar charging of electric vehicles and how to implement it. Specifically, we learned that solar charging can be done via onboard solar cells on the vehicle and through solar panels which are installed on the parking lots and buildings nearby. And finally, we compared AC and direct current DC based solar charging and saw how integrating on direct current DC is more efficient and can be combined with the vehicle to grid as well. Thank you for listening.